implement the control. So then what to do? Using the artificial intelligence, we can develop the model. So how? This is the input, this is the output. So like that we are giving the training. So now it is producing one model. That model, so then again we are giving the different input, we are getting the different output. But we do not know what is inside the model. Okay. So that model is related to the electrical system or mechanical system, that also we do not know. Okay. So that kind of model is called the black box model. So whatever the visible systems, if V is equal to di by dt like that, if you are writing the differential equation in terms of electrical component means that is a white box model. Okay. So mathematical equation, differential equation means that is the white box model. But you are writing the black box model. Black box model means neural model. This is a black box model. Transfer function model. K by 1 plus tau s. Okay. I have given 5 by 2 plus 3s. So I am asking 5 by 2 plus 3s. Is it a RLC circuit or a tank system? It's a chemical circuit. How to know that? We do not know. K by 5 by 2 plus 3s. That's all. One model is there. That model may be electrical model. That model may be a mechanical model. Okay. So, but if you are giving one input, it is giving another output. Okay. So that type of model is called the black box model. Okay. We do not know what is happening inside. So it's a flight means they are having the black box, no. So only they are having the data. Okay. Using the data only we can analyze what to do next line. So that is a black box model. If it is visible, if you are able to understand the process, that model is called the white box model. Then grey box model. So what do you mean by grey box model? Combination of the white box and grey box. Same RLC circuit. So you can analyze how much the voltage across capacitor, then how much the input voltage, current through the everything. Now I want to know current through the inductor. Okay. So current through the inductor I want to know means instead of adding any instrument to measure that one, I can use any soft estimator to estimate the current through the inductor. Because I know that how much the input voltage I am giving, what is the voltage across the capacitor, I know that, current through the resistor, I know that. So if I want to measure the current through the inductor, I can add another algorithm using the artificial intelligence. I can use the algorithm to estimate the current through the inductor. Okay, that is called the grey box model. Combination of white box and black box is the grey box model. Okay, so that is white box means that is the equation is there, RLC circuit is there, equation. Then along with that, we have to estimate current through that one means we can use the another soft sensor. Soft sensor means you know that Kalman filter. Okay, so many estimated things are there using the or in same neural model also you can use. These are the so the neural model or artificial intelligence models are the black box model. Okay, only differential equation, mathematical equation, that is only the white box model. Okay, combination of these things are the grey box model. Okay, so now for the modeling and to implement the optimization. Okay, so for this purpose only, mainly instrumentation and control people, we are using the machine learning, that is the artificial intelligence for optimization and control. So what do you mean by optimization? To increase the maximum efficiency with the minimal effort. We have to find out the minimal effort. Okay. I am from Tamil Nadu. I cannot speak Malayalam fluent. So here optimized way. Okay. So with minimum effort we have to get the maximum efficiency. That is the optimization. Okay, so that in the instrumentation control means we are using for modeling purpose. Model means again we are going to implement the control only. So modeling purpose, optimization purpose and control purpose we are using the artificial intelligence. Okay. So now we are using the predictive analysis and adaptive control. So predictive analysis means we can predict even the forecast, the weather forecast also we can predict. So yesterday 4 o'clock it was rain in Kozhikode. So today also it may be a rain at 4 o'clock or tomorrow also. Like that we can predict. So that is historical data. So last year what was happened in November 18. So in the previous year what was so every year November month evening 4 o'clock is rain is coming. So every year May month morning time is rain is coming. Like that we can predict. So prediction also we can use the AI. Then fault analysis also there, and adaptive control. So adaptive control means we are implementing one control for particular operating system like that. So if any disturbance or out of the region, any disturbance is coming, any environment is coming, that controller has to adapt, it has to give the control action. So that adaptive control also we can use the AA control. If you are using PID control, okay. So PID control you are using means what is the formula for PID control? Mathematical equation of PID control. KPE plus K integral of d dt dE by dt. Okay. So if so this is a mathematical equation. So when the error is coming, it is multiplied by the gain. Gain is a fixed one, Kp. Then integral of error multiplied by Ki. Then differentiation of the error multiplied by the Kd. This is the equation. So the same equation only working throughout the region. Whatever the disturbance is coming. So it will look into the error. How much the error? So how much the gain you have given? Then it will multiply, it will give the output. Okay. So PID means it will add all the value. So now if it is coming out of the range, so you are designing the PID control for particular region or particular operating point. So if the error is coming out of the point, so again the same value. So because the controller has the maximum input value, minimum input value 0 to 100. Controller has to open 0 to 100. After that it cannot open, no, 100% it is open. So now what to do? How to, whether it has to decrease it or increase it? Okay, that kind of situation, AI will think. Okay, so how to minimize, or whether we have to give the alarm to that. So that is the adaptive control. Okay, so whatever the disturbance coming, so the control action will be coming based on the disturbance only. But in case of the error also, in the PID controller also, whatever the error coming, we are getting the output. But what kind of error? Because of any malfunction, because of the faulty condition, that the PID does not know. PID will give output whenever the error comes. Okay. But in case of the artificial intelligence means, we have to train like that. So the operating region is 0 to 100 only. So if any malfunction or any fault is coming, we have to behave like that. We are giving training process. So based on that artificial intelligence will give the control action, or it will give the alarm, it will cut off the wall, like that it will predict and it will take the action. That is called the adaptive control. So we have to adapt based on the environment. Okay. So that also we can use the AI. Then now hybrid approach they are doing. That as I told, the grey box model. So they are using the physics information model, that is PINN. That's a recent research in the PINN. Physics information model along with the artificial intelligence. So that also we can do. Okay. Then AI drives the evolution toward the smart and self-optimizing and fault-tolerant system. Okay. This pointer is not working. I will explain later. I will explain with the example. So here AI mainly used for design purpose and operation purpose. Okay. So design purpose means, that is, nowadays they are using the digital twin. You do know about the digital twin? So digital twin is actually virtual control. Okay. So from here, from here you are here, you can monitor and control in your classroom. The classroom is the next building or the next village like that. You can monitor and control. So that is a digital twin. Same, whatever happening here, as a virtually we can see here. Okay. Then we can control from remote area. That is called the digital twin. So that digital twin also, conventional methods are using there. Nowadays the conventional methods are coming along with that AI, because AI means it is used to predict the actual disturbance and whatever the environment changes, it is predicting. Only conventional method means same as how the PID controller is using as a formula. Digital conventional method means we are mimic the system in the other classroom, we are mimic here. So using conventional method, P&A diagram means only whatever the condition we have given, it will follow. So out of that environment, when any disturbance are coming means only AI is modifying that one. So AI only along with the digital twin, and IA is the recent research area in all the industry, power industry, chemical industry or other manufacturing industry. Digital twin along with the AI. Okay. So then operational means that is a predictive maintenance. So predictive maintenance means in the previously whatever the industry one motor is running, okay. So they will, that operation engineer will be there, a very low level operation engineer trainee will be there. They will check daily how the motor is running. So they will by hearing the vibration sound, they will tell 3 more years we can work this one, like that. Because based on their experience and knowledge, they used to say 3 more years for this lifetime for this machine, like that. So same thing. So every time we cannot depend on the human to analyze how whether this machine is working or how long it will work, like that. So same way now we are using the same historical data. We are using the artificial intelligence to predict that lifetime of that machine. Okay. Then if any fault is coming to that, then immediately that AI is giving alarm to fault is coming. So then they will take it to further maintenance. Okay, it's called the predictive. They are predicting what is the lifetime or it is a fault is about to come. Then we have to take it further maintenance. Or 5 years over, we have to in our house the AC is there. They used to AC people they used to call, madam, this is a service time. We have to come. We have to come, like that. So same way, because they are having the schedule. 6 months once we have to service that AC. But if you are not using AC properly, AC is in working good condition, so unnecessarily that person has to visit and he has to check. Instead of that, using AI means AI will monitor the AC whatever the output, the sensor data, it is monitored. So now the AI will say AC is working in good condition, you need not go for the service. So none, that service person need not come to visit our home. Okay. So otherwise the human means as per his schedule 6 months once he has to visit. Then after checking he used to say, okay madam, this AC is working. That time he used to think, why unnecessarily we have called, why unnecessarily he visited. So these kind of things is eliminated by the artificial intelligence. So artificial intelligence, it is measuring the data using the sensors. Then it is almost monitoring all the process and it is checking every time whether it is fault is about to come or whether it is working condition healthy or not healthy. That condition only is given. So it is healthy means how long it will be working. If not healthy means what kind of the fault is going to come. That also it has to classify. So using the AI only we are doing that operation monitor, that is predictive maintenance and safety purpose. Safety for the person as well as the equipment also. Okay. So here, so engineering without AI means, as I told, that traditional methods cannot be cope up with the recent applications. So engineering with the AI means we always here using the database models to learn the complex input and output relationship. Because if in the example power industry, if you take the power industry, so you know that lot of unit operations are there, boiler, turbine and generator. So the boiler side also that furnace is there and feeding water, feed water is there, and then water distillation things, water treatment things are. Turbine side also cooling tower and everything. So each units we have to monitor using the manual means. We know that in power industry lot of people are there to visit every time. So if you are making as a AA, the digital twin means, so AA, all the data, so all the sensor data, so the same, the turbine data, generator data and boiler data, all the data we are connecting with the AA means, every time from the control room with the AC room, we can monitor how the sensor is working in the field. So whether the sensor is giving the proper output or not. So if any fault is there, that also we can identify from the control room. Otherwise, manually the engineer has to visit and he has to tell. So this sensor is not working, this sensor is working. Like that, they have to, after the confirmation only, the control engineer can identify whether it is working or not. So otherwise, along with the AA means, from the control room only, we can monitor everything. So then we can move for the further research also. So if a boiler or the thermal power industry, previously the output was a 210 megawatt. Now they are moving to the 500 megawatt with the superheated temperature. So superheated, then the boiler also, they are previously drum boiler is there. Then now they are having only the tube boiler. Without the drum, they are making the tube boiler. So they are improving their, to improve the, increase the efficiency, they are modifying the components. So modifying the components means only the human data, we cannot do that one. So by using the AI only, we can collect more data, because lakhs of data will be there. In the generator side itself, we are having lakhs of data. So all the data need to be analyzed and we have to modify for further processing means we have to use the AI only. Okay. So using artificial. Then same way nowadays that digital twins along with the AA means, that is same, the thermal power plant industry, same thermal power plant industry in the virtual thing. Okay. So in the power plant industry, in the morning, one engineer means they have to visit boiler site, they have to check each and every valves and pumps, whether it is working, whether it is a correct position, everything they have to check, and they have the worksheet, they have to note down all the things, and after that only they will conclude in the afternoon, and next shift they are concluding whether all the boiler side everything is working or not. If any valves in that malfunction means, they will check whether you have to give the PR to that valve or next valve. Like that they are checking and they are doing. For in case of digital twin means, you need not go into the field. Okay, from here this room I can monitor through that class, I can monitor. That means visually you can go near to the boiler and you can check whether the valve is working, whether any leakage is there. Everything we can check using the sensor data. Then virtually we can monitor also. So if any persons are coming on means, that also we can check. Okay. So that is a digital twin. So digital twin means all the sensors are integrated. Virtually all the sensors are integrated. So from this room we can monitor only sensor data only we are monitoring. So from then virtually we are, if we are having the camera means, then we can monitor also what is happening there also. Okay. That's a digital twin. So main AI techniques are, as I told, so there are a lot of techniques are available. That is a machine learning, deep learning, reinforcement learning, and knowledge-based learning. Okay. So first, what is machine learning means? That is identify the important pattern from the large data set. So huge data if you are giving, it directly it will identify pattern. Pattern means this is the faulty condition, this is a low level condition, this is a high level condition. Like that it will classify that one. That is a machine learning. So deep learning means it is a subset of the machine learning only, but it is training with a multi-layer neural network. Okay. So deep learning means it is learning thoroughly. Okay. So because the neural network is having the more number of the layer, so thoroughly it is learning means compared to the machine learning, it will identify the exact fault. Okay. So then reinforcement learning means it's mainly used for the optimization and control purpose using the agent, and using the rewards and penalties. So like how we are motivating the student in the classroom. One student got a first mark means we immediately should say clap, and then he got a very good mark like that. Or we are writing in the paper very very good. So that is we are motivating. So then others are getting okay. We need to get very good. So that is a reward. Okay. Penalty means if the student is getting fail mark, go and bring your parents. That is we are giving the punishment. So same way, how we are treating the students, same way we are training to the reinforcement learning. So the reinforcement learning also, whenever it achieves the goal, then reward will be there. If it is lagging behind the goal means penalty will be there. So based on the penalty and the rewards, it is going to learn, it is going to reach the set points. Okay. Then expert system and fuzzy logic. So fuzzy logic, do you know the fuzzy logic is actually used in the real-time system. Daily we are using in our house. We are using the fuzzy logic controller. So do you know which equipment? Washing machine. Okay. So that is only knowledge based. So washing machine, once you are adding the cloths, we are having some option. So that is a cotton cloth or bed sheet, okay, or daily use or quick wash. So only the knowledge. So this kind of the cloths are there. This much water, this much speed of that spin. That's all. So nothing there. Only water level and how much RPM of the that spin. Okay, how much duration that soaking the time, washing time. That's all. A very simple thing, but it's used only the fuzzy logic control. Okay, so different option we are giving different control. Okay, so the fuzzy logic controller we do not give the any values, only the knowledge based. Okay, so knowledge we know that. So these kind of cloths means how much time we are taking time to wash that one. Okay, so like that we are giving the if then rules. Okay, based on the knowledge base we are doing. So first thing is the machine learning, then only the using the large data set, and deep learning means we are giving the more training in the using the neural network layers. Reinforcement learning means, as I told, rewards and penalties, and that fuzzy logic controls and all only the expert system, knowledge based system. Okay. So the machine learning means, so it is mainly it is used for the large complex systems. So when more number of data is there, we are using the machine learning. But mainly it is giving the label as healthy system or non-healthy system. So that is mainly for predictive maintenance or analyzing the system. Okay. Then it predicts the product quality and system performance from the process parameter. But then mainly manufacturing system or the power industry, chemical industry, they are using the machine learning. Okay. Then when you go for the deep learning, as I told, this is a subfield of the machine learning. So the multi-layer neural networks are there. Here also a lot of algorithms are there, CNN and cluster like that. So using that one, we can analyze. So mainly whatever the machine learning cannot do, we can use the deep learning. Okay. So mainly that is a new vibration and acoustic signal to detect the complex fault diagnostic. Okay. So whenever the machine learning cannot identify the fault means we can use the deep learning to identify the fault. Any microscopic effect, any defect, those things also we can analyze using the machine learning. So mainly it is used for the autonomous vehicles and robotics and drones. Okay. Then reinforcement learning means, as I mentioned, it's a behavior of that is a rewards and penalties like that. So mainly the agent will be there. Agent is working on the based on the environment. So environment condition also we have to give what kind of environment it has to work. So in that environment the agent is working. Whenever it is reaching that goal or whatever the environment condition, then it is getting the reward. If it is moving away from the that environment and the goal means it is getting the penalties. Based on that, it is moving towards the goal to achieve that set point. Whatever the set point we are giving, it has to achieve. Okay. So mainly all the chemical industry nowadays they are using the reinforcement learning instead of the PID controller. They are using the reinforcement learning. And manufacturing industry and robotics, and robotics and autonomous system also they are using the reinforcement learning. Okay. Then on the knowledge-based system, as I told, that is a if-then rules only. So previously the fuzzy logic system. Fuzzy logic systems are nowadays they are using very less equipment only. They are moving into that reinforcement learning and deep learning learning. Then these are done. So old method, that evolutionary and swarm particle optimization, PSO, particle swarm optimization, and genetic algorithm. So this is used to search in the group. Okay, so that is we got to search the optimal path in the group. Okay, group wise we got to search. That is genetic algorithm and the particle sum optimization. Okay, PSO and all. So now what's the PSO? We can use it for identifying the PID controller parameters, even fuzzy logic or a neural network, how much the weighting algorithm, those things we can use PSO and genetic algorithm to identify that one. And hybrid AI approach means, as I told, physics informed neural network. Okay, PINN. That is a recent research. That is, neural network is the artificial intelligence using the data we are developing the neural model along with the physics informed. Physics informed means that is a mathematical equation also. So one system is there, we are using the mathematical equation along with the neural network. So whenever the data is not measurable. Okay. So as I told in the RLC circuit, so only you are having instrument for measuring the voltage across the capacitor means, so we can use another estimator, Kalman putter or AA also to estimate the current through the inductor. Okay. So we are having that equation as a conventional method, that is a mathematical equation. Along with that we are having the neural network means that is called the physics informed neural networks. Okay. Because we cannot rely artificial intelligence completely, because we cannot get the more accurate. We are getting accuracy compared to the conventional method. Even though to improve the accuracy, we are combining that mathematical equation, physics informed equation as well as the neural network. That is a PINN. Okay. That is called the hybrid digital twin also. That is digital twin along with the AI approaches. Okay. Then so as that application in the control and automation means, as I told, system identification we are using the AI, and control tuning and fault detection we are using, and model predictive control for weight to find out the weights for the model predictive control we can use AI. Then optimization or unsended Kalman filter also we can use AI for designing that UKF unsended Kalman filter. Then adaptive gain scheduling and predictive maintenance and fault detection and sensor calibration we are using the machine learning. These are the applications for the control and automation system. Then in case of electrical and power system means mechanical and manufacturing system means, that is mainly predictive maintenance using vibration and temperature for any machine to find out the fault. We are using the vibration and temperature and current data analysis. And electrical and power system means power grid, they are using the AI only to monitor the power consumption, because we are having the grid in the all the states means Kerala, Karnataka, Tamil Nadu means they are monitoring using the AI only. How much the power consumption from one state, how much the power supplied from the another state. They are using then reinforcement learning to use the energy optimized energy distribution for all over the states. Okay. Then AI based condition monitoring also they are using. Okay. Then in case of civil and structural means, they are deep learning is used to detect the crack detection and damage localization. Then reinforcement learning means for communication purpose they are using reinforcement learning, that to control the traffic signal and wireless networks. Okay, that's the reinforcement learning. And then main thing, as I mentioned, that is a digital twin. Okay. So a digital twin means that is a virtual replica of the physical system, that is creating a closed loop between the physical asset and the digital model. So one model will be there. For example, one single tank system is there, means single tank system will be there. Same single tank system we have to create another model, that is a virtual model using data. So one single tank system means what is the input of that one flow? Flow is the input level, how much the water inside the tank is the actual output. So water level is the output, flow is the input. So that using the data we can develop the virtual tank system. Okay. So that virtual tank system means, so directly how much the water level inside that one we can monitor from here. So the tank is the tank, but here from here we can develop the virtual tank. So directly even the level is increases we can monitor from this row. That is a digital twin, that is a virtual thing of the physical system. Okay. So here this is also used to do for the forecasting future performance and health and operational behaviors based on the live data. Then physics informed neural networks. So that is physics informed neural network. Hybrid AI approach uses the data driven learning with the differential equation. So all the differential equation based on the physical laws and the electrical system means Kirchhoff's law, then chemical system means mass balance equation, mechanical means Newton's law. Based on that, we are developing the differential equation. Along with that, we are comparing that A. Okay, that is called the physics informed neural network. So here, whenever the data is not available from the sensor, we are not able to measure the data, then directly we can use the artificial intelligence to estimate the data. Okay, that is a physics informed neural network. Then embedded AI. So now that they are using the microcontrollers, and if we see that also they are combining along with the AI. Okay. Then generative AI in the design purpose also they are using that artificial intelligence, and expandable AI. That is as I mentioned that the black box model. So that a complete AI, then using that one we can implement control or monitoring purpose. So now then AI driven as a sustainable engineering. So now the people are also last week also we have conducted one conference, sustainable engineering kind of. So now they are moving to the AI techniques to optimize the entire life cycle of engineering system for environmental sustainability. That is mean again we are going to the olden age. So how we are now we came to the modern era. Then we have to sustain that old thing, we have to move on to the olden thing also. So here that optimize the energy use in the real time for manufacturing and smart grid and HVAC system to reduce the carbon footprint. Okay. So here also it enhances the efficiency for the generative design and predictive maintenance. Then AI in the design of engineering system. So as I mentioned, many application as I told, electrical how they are using, civil how they are using. Here lot of companies how they are using the engineering AI in their companies for engineering application. So for example, for automotive means automotives they are using the that is vibration. So vibration sensor they are using the acoustic noise. They are using the acoustic sensor. They are measuring that noise in the from the motor. Then scientific application research associate they are giving the audio signal classification for the drone navigation. So okay, to find out. Then well drilling equipment and turbine sensing. Okay, so everything they modified with the AI. Different companies I have searched in that. Right? And I added what are the companies, how they are using the AI for their manufacturing company or their applications only. I have added. Then virtual sensor for NOx estimation, the Renault company they are using. And battery, that's electric vehicle means battery charging, and EV vehicles they are using battery charging, and that is a SOH estimation they are using. Then using the AI only. Then energy applications, same that well-bore equipment sensing, and these are the design phase. And in the operation phase means that is Hyundai Steel and energy applications and Airbus and ASML. So everyone for all the manufacturing company mainly for predictive maintenance they are using. Then fault detection they are using. That is if machine learning means deep learning means that visual inspection. This inspection, sorry, visual inspection exactly. So any fault is there, any defect is there, directly they can identify using the image. Okay. So deep learning machine is used to extract the data from the image. Okay. So you know that all the traffic signal we are having AI based camera. So whenever we are going without the two-wheeler, without the helmet, means directly to capture the image, and we are getting the fine through the SMS and that. So now using that the deep learning camera only, using that image they are identifying, then they are identifying the vehicle and the vehicle belongs to whom, everything they are identifying, and they are sending the SMS. Okay, that is the image processing mainly they are using for the deep learning only. So all the steel making company and so if any small crack is there, the stainless steel vessels are there, any small crack is there, they cannot identify using the conventional sensor means they are using the image also, image processing also they are identifying. Then last week we know that Delhi bomb blast also they have identified exact the doctor photo using that image processing only. Okay, so using that AI camera, so now everywhere they have fixed the AI camera using the image processing, exactly they are identifying the people those who are involved in the action. Okay. Then Richard sense of process monitoring. So the process monitoring here just that is used to measure the pin level prediction and the conveyor movement in the thermal power plant. The conveyor movement, how much of gold is stored in that place, and how much that is using that image itself, and they are measuring actually sensor data and along with that image also how much the pin level, how much the cold mood and the conveyor, everything they are using it. Now virtually they can monitor. It is a soft sensor model for this is a pin level prediction. So now using that previously solid level means we are using sensor. Okay, or ultrasonic sensor we are using. Okay, so here now continuously they are taking the sensor data using the AI. Then they are predicting. So whether the level is low or high. So whether we have to stop the conveyor. Everything they are predicting. That means based on the sensor output they are taking the action to continue also. Then personal detection and classification. Okay, so the one group is so any area they are immediately they are identifying the person, and vehicle identification. So what kind of the equipment classification and vehicle identification, whether it's a two-wheeler or car, what color, everything they are identifying using the image processing only. Then predictive maintenance, as I told, they are using the machine learning and deep learning. They are using the MATLAB only. Okay, so MATLAB, same MATLAB is used for image processing as well as data analyzing also. Using that one directly we can predict the possible failures. So using the sensor data and historical data and current data. So they are analyzing all those things, then directly they can predict the failures. So whether that equipment is running this much time and what kind of fault will be coming, everything we can analyze. So everything we have to train using the historical data. So that is we have to run one machine and we have to collect complete data. From the data we have to actually give the classification. So this kind of data is coming means the fault is crack fault or vibration of the fault, like that we have to give. So we have to labeling that data, we have to train the neural network. Okay. So now after that whatever the data is coming, based on the data it is classifying this kind of fault is coming, and we have to take the predictive maintenance, and we can stop the process, or it will affect another process means immediately we have to stop that one. That's a fault detection and predictive maintenance we are using. So that is so main benefit means 90% so prediction accuracy we are achieving that one, and development time cut in the office. If the human is visiting means we are taking more time to analyze and we have to cut off that one. So AI means immediately we have to cut off that operation. Okay. This is everything I have gone through the many research paper. From that paper only I am explaining here. Okay. So from that slides you can select your research area also. So what kind of research work is going on and how the AI can be used for your research. Then mainly oil and gas application. So oil and gas application means they are taking the oils from the sea only. Okay. So previously we have to monitor. Nowadays they are using that image. So they are using AI and that image. They can identify that oil well. Then directly they are going to take that one. Okay. So mainly the oil and gas industry they are using. Then almost that in the oil and gas industry also they are using that equipment data and operation data. Then they have to implement control and instrumentation also. That also they are using the AI only. Okay. As I worked in an industry, that's a wastewater treatment plant. So wastewater treatment plant means that in USA they are collecting the wastewater from the city. Completely they are removing all the wastage from that. Then they are mixing that water, purified water along with the lake. Okay. So here, so only our part is to automating the plant. So we have developed the P&L diagram and we have designed the controller using the PLC only. So using PLC we have to automate the plant. So now then we have to same PID controller only. As of now we have implementing PID control only in the PLC. So now later we can add the model predictive control. You know that PLC means only logic only we are using, on logic. So that logic as of now only PID controller they are using. So now we are trying to implement the model predictive control. Later AA also, AA along with the PLC means we are collecting the data from the sensor and we are analyzing in the offline only. So how to automate the one industry using PLC along with AA. So that also we are doing the research. In my lab we are doing PLC along with the AA and DCS also, distributed control system also we are using. That is the actual instrumentation area. Instrumentation control area means that is the automation process. PLC and DCS along with the AA can use. And then future application means they are using to an oil and gas exploration, and that is using the machine learning only. They are developing and deploy the algorithms and to identify the exactly geometry matrix. Then they can everywhere they are using the MATLAB only. So here month-long, so the long projects also that is minimized to very short period. So within short period we can identify, and that is a drilling prognosis accuracy substantially improved. Okay, so if previously they have to drill the one place and they have to identify whether oil is there or not, oil and gas, again they have to move on to that. So now using the machine learning, the AI data, easily they can identify the place, and the time duration is also reduced. Okay. Then the shell company later uses for the image processing, and then using LSTM network they are using. And then grid also they are using the AI, that is reinforcement agents also they are using for fault recognition, and optimized load distribution, as I mentioned, load distribution. Grid means load distribution, they are using the AI, and it is used for the positive recovery and autonomous grid also. And the technical challenges means actually that is we need more data. First of all, for any AI to train we need more data, but whatever the data we are getting from the reactors which contains a noise also. So pre-processing techniques, lot of pre-processing techniques to remove the noises and to find out if any repeated data are there, we have to remove that. Pre-processing also it takes more times, and as I know told, deep model means that is a black box model. So black box model means we do not know what is happening inside. We just know what we are giving the input and we are getting the output only. That is also one challenge. Then high training cost. As even the reinforcement learning, if you want to use in your using MATLAB means we need a high computing workstation. We need that. Okay. So nearly it is a 5 lakhs or 7 lakhs. That high cost training also. Then system integration. So all the existing control system cannot be integrated with the AAM. So for developing a control system means we have to develop to integrate with the AA. So existing system means we need another hardware to integrate AA and control system. And a lack of universal benchmark testing and verification and certification. So the training and verification, everything also some learning is there. Then ethical and safety issues are there. As you know that when you are using AA means that is so that ensuring the fail safe and determines AA response for the under all conditions. AA is using only the data to analyze that one. So if any failure is coming, but if AA is not able to predict means sometimes the damage will be more. Okay. So that we cannot rely completely on the AI. So then ethical user bias, then transparency and human oversight. As you know that recently we know that the Gemini AI, that photo, that also disadvantage of AI. For we are using more AI means it is collecting our human data. Okay. So that artificial intelligence can become very important for the modern engineering system. So all the modern engineering system, without AI we cannot implement anything. Even in cell phone, from the cell phone up to the maximum power industry, we are using the AI for everywhere, because we are improving the efficiency using AI. Then we are collecting more data, means to handle the data we need a artificial intelligence only. Then the integration of the AI bridges the gap between the theoretical model and as well as the practical. As I told, if the mathematical model is not available, but we need to implement the control, means only we have to rely the black box model using AI. Okay. Then it's promote the adaptability and fault tolerance and improve the performance in the complex environments. Okay. So this is actually first part, and I have an application in the AI for the second part. Shall I continue? So now, what are the common things? That is how the AI is used in the each field, electrical, mechanical. Then what are the different AIs are there? What are the different research field in the different companies? Those things only I got given. Okay, now the particularly what we are doing the research and using AI, even the future trends also. So I am going to explain. So as I told that, you know that our AI work flow. That is first we are collecting the data. So data from the sensors, from the real-time system, the sensor is there. So from the sensor we are collecting the data. That data is called the raw data. Okay. So that raw data, then we are going for the data pre-processing. So the pre-processing means we are cleaning and transform and structure the raw data. That means again we are dividing the data for training purpose and validation purpose and testing purpose. Okay. So as we studied in the neural network, 70% we have to take for training and 15% for validation and 15% for testing.